Hey guys, we're going to go over the review for our test tomorrow. Alright, so our test is focusing on understanding the graphs of trig functions and simplifying trig identities. So at the very top of the review, you actually have 8 trig functions. You have the sine, the cosine, the tangent, the cosecant, which is also 1 over sine, the secant, which is also 1 over cosine, and the cotangent, which is 1 over tangent. Or you could say it's cosine over sine even. And then you have the sine inverse and the cosine inverse. Alright? So, we start off and it says, which trig functions are undefined when sine x equals 0? Okay, so there are lots and lots of ways we can approach this. And in class, I've approached it a couple different ways. Alright, but I want to approach a new way right now. You should have a trig chart. And basically, I'm just saying it should just be a table that looks something similar to this. Okay, I went the wrong way. Okay, so when it says when sine x equals 0, which function are undefined? Well, guys, find 0 on this. Alright, find where sine is 0. So you look at your table and find where sine is 0. So hopefully you can see this. But sine is 0 right there. Okay, you'll see it says sine is 0. Okay, when sine is 0, which two trig functions become undefined? We have it right there. Cosecant and cotangent. So that's our answer. Cosecant and cotangent. Okay, so we can just write cosecant, CSCX, and cotangent, COTX. And number 2 is the exact same thing. Which trig function is undefined when cosine x equals 0? Now, the reason this one's harder is you got to find where cosine x equals 0. Cosine x doesn't equal 0 until pi over 2. And then we see that the two that are undefined are tangent and secant. So tangent and secant. Alright, number 3. Graphically, discontinuities across the domain can be represented with a vertical dashed line. They are known as vertical asymptotes, okay? Asymptotes is A-S-Y-M-P-T-O-T-E-S. Asymptotes. Alright, that's just where we have dashed lines, alright? So like several of our trig functions have asymptotes. Those trig functions that have asymptotes, well here, let's just pull up and look at them real fast. We can see that cotangent has those dashed lines, secant has those dashed lines, cosecant has those dashed lines, and so does tangent. So all 4 of those have vertical asymptotes. The period of sine, cosine, and it's important to know that this applies also to cosecant and secant, all have a period of 2 pi. So that also includes cosecant and secant. The period of tangent and cotangent, I know it doesn't say that, but it's important to know that, is pi. The range of the parent sine and cosine are the same. Write the range in interval form. The range of sine and cosine are both from -1 to 1. And then I'm going to go ahead and talk about the domain. The domain is negative infinity to positive infinity. That's actually really important to know. My second period, I told you guys to actually change. Don't worry about finding the range, find the domain on number 6. First period, I don't think I told you that, so do make sure you know the domain for that as well. Number 7, the range of tangent and cotangent are the same. It is negative infinity to positive infinity. What is the period of the parent tangent function? We've already covered that. It is just pi. That's the same period for cotangent as well. Okay. Number 9, given that y equals tan x, right now placed on the x-axis, we'll have a vertical asymptote. Well, hey, we gave you a graph of tangent. It's right here. I clearly have a vertical asymptote right here at 3 pi over 2, or at pi over 2, or at 0. Okay? So I can put any one of those. It does not matter which one you write. I'm going to put 3 pi over 2, but you could put 5 pi over 2, you could put negative pi over 2, you could put pi over 2, you know, all of those are good options. Okay? Which of the trig functions has 2 vertical asymptotes at x equals negative pi over 2 in one period and goes through the point pi over 4, 1? Well, let's go back and look at these real fast. So it needs to have vertical asymptotes at negative pi over 2 and at pi over 2. So it appears that that does happen on tangent as well as negative pi over 2, pi over 2. That also happens on secant, but it needs to go through the point pi over 4, 1. Secant goes to the point 0, 1. So by the time I move over to pi over 4, it's been increasing. So that means that if I go to pi over 4, it's going to be past a y value of 1. Pi over 4 will actually end up at a y value slightly above 1. So you go to tangent, it goes through the origin, and that pi over 4, which is halfway between 0 to pi over 2, it does seem like it'd be right at about pi over 4, 1. Alright, so our answer is tangent. Write the trig function as ordered pairs at 0, 0, pi over 2, 1, pi 0, 3 pi over 2 negative 1, 2 pi 0. Guys, I grab my hand in a trig chart and I just go down. All right, 0, 0. Well, sine is at 0, 0. Pi over 2, 1. Sine is at pi over 2, 1. Pi 0. Sine is pi 0. 3 pi over 2 negative 1. Yep, that works for sine as well. And then 2 pi 0. Yep, that works for sine as well. So sine x. Very good. All right, the next question really says, which ones are even? Which following trig functions are even? Only 2 are even. That's cosine and secant. The other 4, this question is wrong. It says which of the 2 trig functions are odd. That's not true. Which of the 4 trig functions are odd? All the other 4 are. All right. So that was 12 and 13. In which quadrant of the unit circle is tangent less than 0? Okay. Well, what does it mean to be less than 0? It means to be negative. So which quadrant is less than negative for tangent? Well, I think of it like this. I literally think of a quadrant. I think x is positive, y is positive. X is negative, y is positive. Negative, negative, positive, negative. Then I think I know tangent is y over x. So basically I'm just asking myself, when I do division, what makes something negative? Well, that's a negative and a positive being divided in any combination, whether negative on top and positive on bottom, or positive on top and negative on bottom. So that means if I'm going to be negative, I'm going to be negative in the second quadrant and the fourth quadrant. Second and fourth. In which quadrants is sine positive? Well, I know that sine is the y value, so where is y positive? Quadrant 1 and quadrant 2. So 1 and 2. What is the domain of sine inverse? Well, let's go up here and look at our graph. Sine inverse is this guy right here. The domain is negative 1 to 1. And the range is negative pi over 2 to pi over 2. So I can just write negative 1 to 1. That's the domain. And the range is negative pi over 2 to pi over 2. And then I can go back and look at my graph again and get those answers again for cosine, because the next couple of questions are about cosine. So the domain again is negative 1 to 1, and the range is 0 to pi. So I can go and change that to mean 0 to pi. So the domain is again negative 1 to 1, but the range, and these are both brackets, is 0 to pi. Okay, now I kind of flew through those because I want to really focus on helping you simplify. The rest of those questions, guys, you should be able to look at the graph and kind of get those answers, and we've covered those several times in class. The simplifying is the hard part. Cosecant over cotangent. Alright, so I start off. Every problem I'm going to start off like this way. I'm going to look for any Pythagorean identities. Then I'm going to look to distribute. Then I'm going to look to simplify. And if I haven't simplified enough yet, I'm going to look to change everything to sine and cosine. That's my last attempt at finding it. And then simplify after that. No Pythagorean identities, no distributing, so I'm going to change everything in terms of sine and cosine. Cosecant can be changed to 1 over sine. So I have 1 over sine over cotangent can be changed to cosine over sine. Okay, so now I have a fraction divided by a fraction, so I keep the numerator. So basically I'm dividing by the reciprocal. I'm multiplying by the reciprocal. So I keep the numerator, flip the denominator, and change from division to multiplication. Alright, so now that I have a sine on top and a sine on bottom, I can cancel them out, and it becomes 1 over cosine, which 1 over cosine is really just secant. So secant theta. There you go. Alright, 21. Alright, first thing I do is I look for any Pythagorean identities. Ding, 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 that's a Pythagorean identity. It comes from the Pythagorean identity sine squared theta plus cosine squared theta is equal to 1. If I was to move the sine squared over, I would get 1 minus sine squared. I'm sorry, not the sine squared, my apologies. The cos, if I was to move that over, I would get 1 minus cosine squared theta, so I'd be able to instead put sine squared. And then I know that cosecant is actually 1 over sine. So then I know I have a sine on top, a sine on bottom. One cancels out from the top, the only one on the bottom cancels, and I'm left with just sine overall. Alright, 22. No Pythagorean identity, nothing to distribute. So the next thing I'm going to do is I'm going to actually change in terms of sine and cosine. So sine stays sine. Cotangent is going to change to cosine over sine. And then secant is going to change to 1 over cosine. Alright, and then I notice that I can cancel out my cosines, I can cancel out my sines, and I'm left with just a 1 overall. Alright, 23 says sine squared over secant squared theta minus 1. Okay, secant squared theta is a Pythagorean identity. It comes from the Pythagorean identity of 1 plus tangent squared is equal to secant squared. So if you were to move that positive 1 over, okay, if you were to take this 1 and move it over, that would make it a minus 1. So then I'd have secant squared theta minus 1 right here, and it'd be equal to tangent squared theta. So I can rewrite this as sine squared theta over tangent squared theta. Okay, now at this point in time, that's where I say, okay, so I've done that, so let's try to, I can't distribute anything, so let's try to change things in terms of sine and cosine. So I'm going to change tangent squared to being sine squared over cosine squared. That's one of its quotient, that's one of, quotient identities. So now I have something divided by a fraction, so I keep the sine squared on top, and then I flip my denominator, so it becomes times cosine squared theta over sine squared theta. I get to cancel out the two sine squares, and I'm left with just cosine squared overall. So cosine squared theta overall is my answer. Okay, moving on. Problem 24. Alright, there's no Pythagorean identities going on yet. Keyword. Alright, so the next thing I'm going to do is I'm going to distribute cosecant times cosecant. That becomes cosecant squared theta. And then I do cosecant times cotangent. So that just becomes cosecant theta, cotangent theta. Alright. Then I do negative cotangent times cosecant, so I get negative cotangent theta, cosecant theta. And then I do negative cotangent times cotangent, so that gives me negative cotangent squared theta. At this point in time, I notice that my two middle pieces are the same thing, but different signs. Cosecant cotangent and cotangent cosecant are the same thing, guys. Just like x times y is the same thing as y times x. So cosecant times cotangent is the same thing as cotangent times cosecant. So it's kind of like this is saying plus 2 times 3 minus 3 times 2. So that means I could cancel those out. So I'd be left with cosecant squared theta minus cotangent squared theta. And that is one of my identities, and that is simply 1. That's one of my Pythagorean identities. Alright, number 25. When I look right here, I see in my denominator, that's a Pythagorean identity. Tangent squared theta plus 1 is the same thing as secant squared. And then I'm able to cancel out the square and get rid of that secant. So now I have tangent over secant. So I'm going to change tangent to being sine over cosine. And I'm going to change secant to being 1 over cosine. So now I have sine over cosine divided by 1 over cosine. Keep the numerator, so sine theta over cosine theta, times the reciprocal of the denominator, so that's cosine over 1. The cosines cancel, and I'm left with sine on top, so I get just sine theta for number 25. Alright, number 26. Cosecant, what did I just do? Alright, 26. Tangent squared theta minus secant squared theta. That's actually one of my Pythagorean identities slightly adjusted around. Okay, let me show you the one it comes from. It comes from 1 plus tangent squared theta is equal to secant squared theta. Okay, now what they've done is they took the 1 over here but took the secant squared theta over here. So it became tangent squared. Tangent did not change equal sides, but the secant came over, so it became minus secant. And then when that positive 1 goes over to the other side, it becomes a negative 1. So my answer is a negative 1. Alright, number 27. Alright, we're doing 27. It's important to realize, guys, that this is a block. Okay, it multiplies all together. So we're going to distribute this times this, and then that whole thing times that. So when we multiply this times this, we get, I'm trying to type it out, see if I can't do that a little bit neater. I get cosecant x times secant x times sine x, then plus, and then I do this times this, so I get cosecant x times secant x times cosine x. Well, now I have some stuff I can do. I know that cosecant is really just 1 over sine. And if you remember earlier, we talked about how when you're multiplying, the order doesn't really matter. So that means this sine and this 1 over sine can cancel each other out, and you're left with just secant. So secant x plus, and then over here, secant is really the same thing as 1 over cosine, and it gets to multiply with this cosine, so they cancel each other out, and you're left with cosecant. And that's as far as you can go. There's your answer. All right, 28, last but not least. I'm going to write upwards because I can't really write down anymore. Cotangent is really, all right, so look, there's no Pythagorean theorem here. There's no Pythagorean identity, so I can't change anything based on that. There's nothing to distribute, so I can't do that. So I'm going to change things in terms of sine and cosine. Cosine is already in terms of sine and cosine. Cotangent can be changed to cosine over sine. And then sine is already in terms of sine or cosine. Well, I have a sine on bottom and a sine on top, so they cancel. Cosine plus cosine is 2 cosine x. And there we go. Okay, guys, I tried to go fast. If something did not make sense, please do not hesitate to reach out to me over Canvas, over email, over Remind. All right? Any way you need to get a hold of me, please do so. All right? Any questions you have, I will answer tonight. Please send me a Remind, send me an email, reach out to me over Canvas. I'll do anything I can to help you. All right, guys, have a wonderful evening. Study hard. Thanks.